Alright, going back to our project, and now I'm going to show you how to write tests for this nearest neighbors function that we have. So what we can do is we can get a new R script. We're going to save this in the, well, we have to make a new folder called tests. And inside that tests folder, we're going to have to make a new folder called testthat, no space, all lowercase. And then we're going to need a file test dash and then anything you want, knn, but it has to end with .r. And inside of that file, we want to call our library nearest neighbors demo. We want to call library testthat, that's the testing framework. And then we also want to call library, we want to use one of the testthat functions, which is called context, to tell us the context of this test. So what we want to do is we want to add one or more of these testthat blocks, and the first thing should be a character string which completes the sentence testthat, knn computes same answer as R, for example. So then you get this block, which you can delimit in these curly braces, where you can write whatever R code you want to test your code. So, for example, let's go back to our knn.r function. Where is that? knn.r. All right, here we have some example code, which we can also use for our test. How about that? So let's uncomment that. How do we do that? Code, uncomment lines. There we go. Then what we're going to do here is let's run it on a bigger data set, say like 100 data points. And well, actually, for the testing, for this demo, let's just use the same 5 data points for the train and this 1 data point for the test. So running this code again, what do we get? Okay, we could not find function knn. That's because we haven't loaded the library yet. Let's do that. Okay, and so knn gives us this vector of predictions 1, 1, 1, and so I mean, one thing that we can do is that we can let's save that in a result vector. Let's call it predvec, and then so in this test, what we should do is we should compute for these training data. What are the actual distances and in R, and let's make sure that this is actually getting the right answer. So here we have test X. This is our test data point. Let's compute the distances between this guy and all of the training data points. So to do that, we need to consider so test X is considered as a row vector, or a column vector. Actually, it looks like it's printed out like this kind of long row vector, but actually, for computation purposes, if we have this X here, which is a matrix with 3 observations of rows by 256 columns, well, actually, to compute the differences between that and test X, we're going to need to compute the transpose of the matrix first, and then compute this difference here. Then this will give us the matrix of all of the differences for is that right? Yeah, that's right, for all of the training data points. So then what we have here is we have the distances for all the training data points on columns, because we took the transpose of all of the different dimensions on the rows, right? So those are the different pixels in these images. And so what we can do to compute the distance here is, well, let's save that as like the distance matrix. And then what we can do is we can take the row sums of, sorry, the call sums, because we want to get the sum of the distances of all of the, so this is the sum of the square distances of all of the data points, but we also have to take the square root of that to get the L2 distance. Right, so that would be dist vec. Let's see what that looks like. Whoops. Oops. That should be dist mat. Let's see what that looks like. Alright, so that's a vector of distances. We can get sorted index vec. That's going to be order of dist vec. So sorted index vec looks like this. It's a vector of indices. The closest one, so this is the closest nearest neighbor is the fifth one. The second closest is the first one. That makes sense. So this is the smallest distance, the fifth one. And the second closest is this first one, etc. Right? And so then what we have to do is we have to select the indices of the k near. So let's save this as max neighbors. Max neighbors. Max neighbors is 3. And so then we can refer to that here. So what closest indices, so this is going to be sorted index vec of max 1 to max neighbors, right? We just want to consider the closest ones. All right, let's define that. We're going to rerun all that code. And so then we see the closest indices. Well, that's just these first 3, right? And then what we can do is we can look at the labels of the closest indices. And we see indeed they are all 1. But to be precise, what we would want to do is we would want to compute the, well, I mean, to be a little bit more illustrative, let's take the 4 nearest neighbors here and see what that looks like. So, well, we see since in the input data set, there's right, the training labels, there's 3 1s and 2 zeros, so this is a bit more interesting. If we do the 4 nearest neighbors, one of them's got to be a 0, right? So then what we can do is we can compute what should the prediction be, and so that would be in R. You can use the cum sum function to get the cumulative sum, and then you can divide by. Well, actually, I think can you use cum mean actually? No, it's not actually a function. We can use cum sum, then divide by the number of data, there. So that would be 1 to max neighbors, right? And so that would, this is the kind of expected. Well, actually, that's not right, is it? So let's see if we can debug this. You're right. So the cum sum should be here. Cum sum should be of all of these guys, and then divide by 1 to max neighbors, right? And so that means, so the nearest neighbors prediction is 1 for all of the first 3 nearest neighbors, and then it becomes 0.75 because then the one of the 4 nearest neighbors is a 0, right? So we can save this as expected prediction, and we can also, now write a test to make sure that this pred vec here from the k nearest neighbors is the same here. Let's check, right? Well, it is indeed, but let's write a test to make sure. Expect equals pred vec expected prediction. So here we have a test where we're computing nearest neighbors using our C++ code here, but we're also computing it using our R code here, and we're using this expect equal to enforce that it's the same. So So here, when expect equal doesn't return anything, that means the test passes just fine. So you can run the whole test like this interactively, or you can hit Control-Shift-T, and that's going to run the tests in this pane over here. And so you can see that the one test that we wrote here is okay. And furthermore, when we use Control-Shift-E to do the checks, it's going to show that one of the things it's going to do is going to run the tests, and then it will stop with an error or warning if any of the tests don't pass. So let's look for that. Well, actually, so test, right, so actually it did not run the tests. And the reason why is because we need to actually write a test file for it to run during checks. So to do that, we need one more code file here, new text file, save inside of the test directory. This is going to be called testthat.R. And so basically in this file, we're just going to be telling the package to run all the tests in the testthat directory. And to do that, you do library testthat and then test check, and you give the name of your package. And this is going to be nearest neighbors demo. And so when you run that, it's it says no test found for nearest neighbors demo, but that's not true. Maybe because we're using an old version. So why don't we rerun and reinstall? So there we go. Then when we do test check, well, it's still not working. Well, that's odd. But let's try Control-Shift-T, and that's rerunning the test, but that's not what I want to do. I want to do Control-Shift-E to rerun all the checks. So the difference between the tests and the checks, the tests are, these are all these files that you're writing to test specific functionality. Checks are this kind of standardized system of checks that makes sure your package is going to work with everybody else's online. So so here we have now some warnings that came up in our check. Checking for unstated dependencies in tests. Running testthat.R. So now it's actually running it. So the problem here is that library or require call not declared from testthat. And so when we get something like this, that means we need to go back to our description file, and we need to go against suggest testthat. When you have something that you're using in your test, you can when you have another package that you're using just in your tests or your examples, you can put that under suggests, and that will get rid of that warning. So let's try that again. Control-Shift-E to recheck the package. And so hopefully that will run all the tests, and that will pass without warnings now. Right, so here we have running testthat.R. It ran just fine, and there's no issues. So we only get one note, and that should be fine. Okay, thanks for listening to this tutorial about how to write tests for your package.